Imagine staring at the night sky, seeing nothing but a patch of darkness. No stars, no light, just an emptiness that seems to swallow everything around it. For centuries, humanity gazed upward, trying to make sense of the heavens, unaware that hidden among the stars could be something far more terrifying than they had ever imagined. Something so powerful that not even light itself could escape. This is where the story of the black hole begins. The idea of black holes didn't suddenly appear out of nowhere. Back in the 18th century, an English scientist named John Michell speculated about what he called a dark star, an object so massive and dense that its gravity would trap even light. At the time, it sounded like pure fantasy. Technology was primitive, and humanity's understanding of the universe was still in its infancy. Most dismissed Mitchell's concept as little more than wild imagination. Then came the early 20th century, when Albert Einstein reshaped our understanding of the universe. His general theory of relativity in 1915 revealed that space and time were not rigid, but could bend and curve around massive objects. From his equations came an unsettling possibility that somewhere in the universe, space-time could collapse infinitely, creating a point where all known laws of physics would break down. That point was what we now call the singularity, the heart of a black hole. Ironically, Einstein himself didn't fully believe such objects could exist. He thought they were simply a bizarre side effect of his mathematics. But soon after, other scientists began taking the possibility seriously. Karl Schwarzschild, a German physicist, solved Einstein's equations in a way that described exactly how such an object could exist. It was the first true glimpse of what we now call a black hole. Think about how terrifying that idea must have been at the time. A place in the cosmos where reality itself ceases to exist. A place that swallows light, matter, even time. How could the human mind truly comprehend something that cannot be seen, touched, or explained by normal logic? Yet, precisely because of that, black holes became one of the greatest mysteries in science. Over the years, astronomers began collecting indirect evidence. They couldn't see a black hole itself, but they could see its effects. Light from nearby stars bending strangely, streams of gas heating up as they spiraled inward, stars orbiting at impossible speeds. All of these signs pointed to the same conclusion. Something massive and invisible was lurking in the darkness, and that led to even deeper questions. What happens inside a black hole? Does matter simply vanish into nothingness? Or is there something beyond the event horizon, a doorway to another world, another dimension, or perhaps even a parallel universe? These questions transformed black holes from a scientific curiosity into fertile ground for speculation, conspiracy theories, and modern myths. A black hole is not just an astronomical object. It is a symbol of the unknown, a reminder of how small we are in the face of the cosmos. From its mathematical beginnings to the hunt for real evidence in the stars, the black hole has captured human imagination in a way few discoveries ever have. Imagine standing at the very edge of something that defies explanation, a boundary called the event horizon. This invisible line marks the point of no return. Once anything crosses it, there is no escape. Not even light can break free. But the greatest question that has haunted scientists, philosophers, and storytellers alike is this: what lies beyond that boundary? From the moment black holes were first theorized, debates erupted. Some argued that everything falling in would be crushed into a singularity, a single, infinitely dense point where matter ceases to exist as we know it. But others dared to dream that perhaps a black hole isn't an ending at all. Perhaps it's a gateway. Imagine a cosmic doorway, a passageway linking us to realms beyond our comprehension. This idea gave birth to the concept of wormholes, tunnels through space-time that could connect distant corners of the universe. And if a black hole is the entrance, could there also be an exit? Some scientists have speculated about the existence of white holes, the opposite of black holes, places where matter is expelled instead of consumed. If black holes and white holes are connected, then the implications are staggering. Intergalactic bridges, shortcuts across the cosmos, or perhaps even pathways to parallel universes. Of course, none of this has been proven. No human has ever entered a black hole and returned to tell the tale. All we have are equations, theories, and imagination. But that uncertainty is exactly what makes black holes such fertile ground for myths and conspiracies. Some believe that advanced alien civilizations might already know how to harness black holes, using them as engines for interstellar travel. Others claim black holes are evidence of multiverses realities layered one on top of another, hidden behind the fabric of spacetime. Now, imagine if that were true, if, behind every black hole, there is another world, another reality, a realm where physics plays by rules we cannot yet fathom, a world where time might flow backward, or where life has evolved into unrecognizable forms. This is no longer just science, it becomes philosophy. Because if black holes truly are gateways, then we must ask ourselves, what does that mean for our place in the universe? The mystery deepened when astronomers discovered that nearly every galaxy has a supermassive black hole at its core. Think about that. At the very heart of the Milky Way lies a cosmic monster known as Sagittarius A*, millions of times more massive than our Sun. What secrets does it hold? Is it merely a star-devouring beast, or is it concealing something much greater? Something the universe itself doesn't want us to know? These questions make black holes more than astronomical phenomena. They are symbols of our relentless curiosity, reminders of humanity's eternal quest to reach beyond the unknown. If the answers remain forever out of reach, the discovery of black holes wasn't the result of a single moment of brilliance. It was the culmination of centuries of curiosity, research, and humanity's refusal to accept the limits of its own knowledge. If we trace the story back, the idea first emerged in the late 18th century. John Michell, an English natural philosopher, wrote about what he called dark stars, objects so massive that not even light could escape their gravity. At the time, it sounded more like a thought experiment than hard science. But everything changed with Albert Einstein's theory of general relativity in 1915. For the first time, science had a framework that showed how space and time could be bent by mass. The greater the mass, the deeper the curvature. From this idea came a startling possibility: objects so massive and dense that they would warp space-time to the extreme, creating a point of no return. That was the birth of what we now call black holes. Even Einstein himself doubted whether black holes could really exist. He believed they were mathematical oddities, not physical objects. Yet Karl Schwarzschild, a German physicist, discovered an exact solution to Einstein's equations while serving on the front lines of World War I. His work laid the groundwork for the idea that black holes could be real. Tragically, Schwarzschild died shortly after, leaving behind one of the greatest unsolved mysteries in physics. By the mid-20th century, observational evidence began to stack up. Astronomers noticed stars orbiting around invisible objects, as though being pulled by an unseen force. One of the most famous discoveries was Cygnus X1, a powerful X-ray source in the constellation Cygnus, believed to be caused by matter spiraling into a black hole. For many skeptics, this was the turning point, the moment black holes went from theory to reality. With the advancement of technology, the evidence only grew stronger. Telescopes in orbit, satellites designed to detect X-rays, and eventually the Hubble Space Telescope gave us glimpses of the universe's most extreme objects. And then, in 2019, history was made. For the first time, humanity saw the face of a black hole, the glowing ring of matter circling the darkness at the center of galaxy M87, that eerie orange halo. Surrounding a void of absolute blackness was undeniable proof. Black holes are real. But here's the catch. The more we learn about black holes, the stranger they become. If they are simply astrophysical objects, why do they seem to defy the very laws of physics? Take the information paradox, for example. According to the laws of physics, information can never be destroyed. But what happens when matter falls into a black hole? Is it erased forever, or is it somehow stored, hidden beyond our reach? Stephen Hawking himself wrestled with this problem for decades, even revising his own theories as new ideas emerged. To this day, the black hole information paradox remains unsolved. This is where the line between science and speculation begins to blur. To some, black holes are just cosmic phenomena, but to others, they're much more. Conspiracy theorists argue that organizations like NASA and other space agencies know more than they're willing to share. That the black holes we observe may be far more than just star-eating monsters. Could they be hiding gateways, alternate realities? The truth, if revealed, might change everything we think we know about the universe itself. Behind the dazzling beauty of the night sky, filled with billions of stars, lies a dark and terrifying truth. At the very heart of almost every galaxy, including our own Milky Way, lurks a cosmic monster, the supermassive black hole. While ordinary black holes are formed from the death of massive stars, supermassive black holes are something else entirely. Their masses can be millions, even billions of times greater than that of our Sun, and they sit at the center of galaxies, orchestrating the movement of stars like a hidden conductor leading a cosmic symphony. Imagine a vast city of stars, billions of suns moving in harmony. Yet, all of that motion, all of that galactic dance, is dictated by an invisible force in the middle, an object so dense and powerful that nothing, not even light, can escape it. That object is Sagittarius A*, the supermassive black hole at the heart of our Milky Way galaxy. Astronomers have detected its presence by watching how stars near the center move. Some stars whip around at impossible speeds, their paths betraying the gravitational grip of something massive and unseen. But Sagittarius A* is not unique. Almost every galaxy we've studied seems to have a supermassive black hole of its own. Our neighbor, the Andromeda Galaxy, hides one as well, waiting for the day it collides with the Milky Way billions of years from now. And then there's the giant elliptical galaxy M87, home to a black hole with billions of solar masses. This was the black hole that made history in 2019 when the Event Horizon Telescope captured its image, the now iconic glowing orange ring, surrounding a void of pure darkness. The discovery of supermassive black holes raises profound questions. How do they form? Do they start as small black holes that slowly feed on their surroundings, until they reach monstrous proportions? Or do they collapse directly from primordial clouds of gas in the early universe? No one truly knows. Some scientists have even wondered whether their existence hints at laws of physics we haven't yet discovered, as if these titans are part of some deeper cosmic design. What's even more astonishing is the possibility that supermassive black holes may actually shape the galaxies around them. Without their immense gravitational influence, galaxies might never have formed as we see them today. The energy unleashed as matter falls toward them can regulate the distribution of stars and gas, influencing the birth and evolution of entire galactic systems. In other words, supermassive black holes aren't just destroyers. They may also be creators, architects of the cosmos itself. And yet, their mystery continues to inspire speculation far beyond astrophysics. Some conspiracy theories suggest that galactic centers are not just home to black holes, but portals to other realms. Perhaps advanced civilizations, or even humans in the far future, have learned to harness their immense energy, using them as gateways to traverse space, time, or dimensions we can't even imagine. It may sound like science fiction, but if it were true, then the heart of our galaxy would not simply be its center of gravity, but also the center of something far greater, hidden truth about the nature of reality. This is the paradox of supermassive black holes. They are real, their influence undeniable, and yet their true nature remains veiled. They are both destroyers and creators, monsters and mysteries, architects and enigmas. And perhaps that's what makes them the most haunting entities in the universe. Imagine standing at the edge of an abyss, a boundary where everything you know about the universe comes to an end. This is the event horizon, the invisible line that defines a black hole. Beyond it, nothing escapes. Light itself, the fastest thing in existence, is trapped forever, swallowed by an eternal darkness. The event horizon isn't a surface in the physical sense. It's not made of matter, but it's real all the same, a point of no return. To a distant observer, the event horizon looks like a glowing ring surrounding a void. Objects falling toward it appear to slow down, their light stretching into red as if time itself were freezing. But to the object plunging inward, nothing feels unusual. It crosses the horizon in an instant, unaware that it has just passed the most terrifying threshold in the cosmos. This is where the mystery of black holes becomes most intense. Near the event horizon, space and time are warped beyond recognition. The rules of physics we rely on begin to falter. From our perspective, we see matter fall and then freeze, but from within, the fall continues without hesitation. It's a paradox that shakes our understanding of reality itself. And then comes the greatest question of all. What happens to information inside a black hole? According to the laws of physics, information cannot be destroyed. Yet black holes seem to erase everything that crosses their boundary. Is the information somehow encoded on the surface of the event horizon, as the holographic principle suggests? Or does it vanish forever, evaporating with Hawking radiation, leaving behind an unsolvable paradox? This isn't just a scientific puzzle, it's a philosophical crisis. If information can be destroyed, then the laws of physics as we know them may not be absolute. But if it survives, then it must do so in a way we don't yet understand, hidden behind the veil of the event horizon. Waiting for some future revelation, to some, the event horizon is not an end at all. Conspiracy theories and speculative physics alike have painted it as a gateway, a portal to another universe, another dimension, another reality altogether. To cross the horizon may not mean destruction, but transformation and entry into the unknown. The event horizon is, in many ways, the ultimate metaphor. It is the edge of knowledge, the boundary where human science falters and mystery begins. It is the line between what we can explain and what we cannot, and the closer we look into the darkness, the more it looks back at us, daring us to ask the questions we may never be able to answer. In the early days of black hole science, these objects were thought to be eternal. Once formed from the collapse of a massive star, they would exist forever, endlessly consuming matter and energy, unstoppable and immortal. But in 1974, a young British physicist named Stephen Hawking shocked the scientific world by proposing something radical. Black holes are not eternal. They can, in fact, slowly evaporate. They can die, and the process by which this happens is now known as Hawking radiation. Hawking reached this astonishing conclusion by attempting something bold, bringing together two of the most powerful yet conflicting theories in physics: general relativity and quantum mechanics. General relativity governs the vast cosmic stage, describing how space and time bend under the influence of mass. Quantum mechanics, on the other hand, rules the microscopic world, where particles flicker in and out of existence. These two theories rarely coexist peacefully, but Hawking realized that the event horizon of a black hole might be the place where they collide. In quantum theory, even the emptiest vacuum is not truly empty. Virtual particles and antiparticles constantly pop into existence, only to annihilate each other almost instantly. But what happens if this process occurs right at the edge of an event horizon? Hawking suggested that sometimes one particle falls into the black hole while its partner escapes. To an outside observer, that escaping particle looks like radiation leaking from the black hole itself. In effect, black holes emit energy. This leads to a profound implication. If a black hole emits energy, it must lose mass. Over time, it shrinks, heats up, and eventually vanishes in a final burst of radiation. For stellar mass black holes, this process takes longer than the current age of the universe. But for smaller black holes, hypothetical ones that may have formed in the early cosmos, the evaporation could be much faster, and with this revelation comes a deeper mystery. What happens to the information swallowed by the black hole once it evaporates? Does it disappear forever, defying the very foundations of physics? Or is it somehow encoded in the Hawking radiation, hidden in a way we do not yet understand? This is the root of the infamous black hole information paradox, a puzzle that continues to divide and challenge physicists to this day. For some scientists, Hawking radiation represents the first step toward a grand unification of quantum mechanics and gravity. But for others, especially those inclined toward conspiracy or speculative thinking, it's something far stranger. Could Hawking radiation be more than just energy? Could it be a message, a cosmic code we've yet to decipher, perhaps from another civilization, or even another universe? Some have even suggested that black holes don't truly vanish, but transform into gateways, leaving behind doorways to realities beyond our comprehension. Whatever the truth, Hawking's discovery changed the way we see black holes forever. They are no longer immortal monsters lurking in the cosmos. They are dynamic, evolving entities. They are born, they grow, and they die, just like stars, galaxies, and perhaps even the universe itself. In the end, not even the mightiest of cosmic titans can escape the relentless march of time. Since the dawn of time, when humans first gazed at the star-filled night sky, Imagination has always stretched beyond what the eye could see. We have wondered, are there shortcuts in the universe, secret passageways that could connect one side of the cosmos to another? And in that pursuit of answers, black holes often emerge as the ultimate key. Could these cosmic monsters be more than just destroyers of matter? Could they actually be gateways? In the realm of science, the concept of wormholes, sometimes called Einstein-Rosen bridge, captures this very idea. Albert Einstein and Nathan Rosen suggested that the equations of general relativity might allow tunnels through space-time, a cosmic shortcut linking to distant points in the universe. Imagine a road that cuts straight through the very fabric of reality, making a journey of millions of light years possible in a single moment. Theoretically, such wormholes could be born from the extreme conditions around black holes. Some physicists speculate that a black hole could serve as the entry point, and if there is an entry, then surely there must be an exit. Does that mean on the other side of a black hole lies a white hole, a cosmic opposite that doesn't pull matter in, but violently expels it out? The question has sparked endless debates. Is a black hole the end of everything, or the beginning of something greater? For conspiracy theorists, the possibilities are limitless. Some believe that advanced alien civilizations have already mastered this knowledge, using black holes as intergalactic highways. They no longer obey the speed of light barrier, because they can leap through hidden wormholes buried within singularities. Others push the theory further, suggesting that black holes aren't just shortcuts across galaxies, they're portals into entirely different dimensions, parallel realities that coexist alongside our own. Even human experiences have been tied into these ideas. People who report near-death experiences often describe being drawn through a tunnel of light. To some, this sounds eerily like what it might feel like to cross an event horizon, a fleeting brush with the doorway to another world. Could consciousness itself briefly travel through a kind of wormhole when the body teeters on the edge of death? Skeptical scientists point out that wormholes, while mathematically possible, would be catastrophically unstable. The energy required to hold one open would dwarf anything humanity could ever hope to produce. But for conspiracy-minded thinkers, this only fuels suspicion. What if secretive organizations are already conducting experiments to crack open such gateways? Could massive projects like CERN be more than just physics laboratories? Could they be covert attempts to create mini black holes and tap into alternate dimensions? The fascination deepens when we look at ancient cultures. The Egyptians spoke of Duat, a realm beyond death. The Maya imagined an underworld filled with cosmic passageways. Were these myths pure imagination, or encoded knowledge from experiences humanity once had but could not fully explain? Perhaps black holes are the physical manifestation of what our ancestors described in myth and spirituality. The idea that black holes could be wormholes or gateways into other dimensions reveals just how profoundly mysterious our universe remains. Science tries to model it with equations, while conspiracy theories fuel our imagination with possibilities. Maybe both perspectives are necessary, because until we cross the event horizon ourselves, we will never know whether it hides only darkness or a doorway to eternity. When we talk about black holes, our minds often focus on singularities, event horizons, and the sheer destructive power of these cosmic monsters. But if we zoom out to a broader cosmological scale, a far stranger connection emerges, one that links black holes to dark energy, the invisible force that remains one of the greatest mysteries of the universe. Dark energy is the name scientists gave to explain an astonishing discovery in the late 20th century. By observing distant supernovae, astronomers realized that the universe wasn't just expanding, it was accelerating. Something unseen was pushing galaxies apart faster and faster, defying the pull of gravity. That unknown force was called dark energy, and decades later, its true nature remains as elusive as ever. So, what does this have to do with black holes? At first glance, they seem like opposites. Black holes pull everything in with irresistible gravity, while dark energy pushes space itself outward. Yet some bold theories suggest a hidden connection between the two. One controversial hypothesis claims that dark energy might actually be linked to the collective influence of black holes scattered throughout the cosmos. In this view, black holes aren't isolated predators, they are part of a cosmic network, pumping energy into the fabric of the universe and driving its expansion. Each black hole could be seen not only as a point of collapse, but as a kind of energy node influencing the entire cosmic balance. Of course, this remains speculative, but conspiracy theorists take it much further. They argue that agencies like NASA already know far more about this connection than they let on. What if research into dark energy isn't just about science, it's about control? Imagine if black holes could be harnessed as limitless sources of power, capable of fueling entire planets or unlocking technologies that allow us to leap across galaxies. Some scientists even speculate that dark energy may be tied to quantum vacuum fluctuations, the restless energy that exists even in empty space. If black holes interact with this quantum vacuum, then they might serve as direct conduits between the most massive objects in existence and the invisible force that makes up nearly 70% of the universe. Could black holes be cosmic anchors, bridging our reality with the unknown energy that drives creation itself? Mystics and alternative thinkers add yet another layer. To them, dark energy is not just physics, it is the soul of the cosmos, an eternal breath that sustains everything. In this perspective, black holes are not just ends, but channels. Every time a star collapses into a black hole, it contributes to this hidden reservoir of power, weaving itself into the spiritual fabric of the universe. If the link is real, new questions arise. Will dark energy continue accelerating the universe until everything is torn apart in a big rip? Or could it eventually reverse, collapsing space back into a singular beginning, a cosmic rebirth? For now, we remain in the dark. Scientists scan the skies, searching for answers, while conspiracy theorists whisper that the truth is already known but hidden. Either way, the mystery reminds us of one profound truth. The universe is far more complex, far more wondrous, and far more mysterious than we can possibly imagine. When we gaze toward the heart of our Milky Way galaxy, we know something massive lurks there. A supermassive black hole, called Sagittarius A*, weighing millions of times more than our Sun, sits at the very core of our galaxy. And from that region come mysteries that continue to haunt humanity. Strange signals that our telescopes and detectors here on Earth have captured. Back in 1977, an astronomer named Jerry Emmon detected a powerful narrowband radio signal while working with the Big Ear radio telescope at Ohio State University. It was so clear and so unusual that he famously wrote "wow" in the margins of the data printout. Decades later, the "wow" signal still remains unexplained. Some believe it may have been a message from an extraterrestrial civilization, while others wonder if it could somehow be linked to mysterious activity around the supermassive black hole at our galaxy's core. As technology advanced, we began detecting even more puzzling phenomena. Fast radio bursts, or FRBs. These bursts last only milliseconds, but release as much energy as the sun emits in days. Many scientists attribute FRBs to exotic astrophysical objects like neutron stars or pulsars, but others believe the story isn't that simple. Some suspect these bursts might be connected to interactions around black holes or, perhaps something far stranger, like deliberate signals sent across the cosmos. Conspiracy theories add another layer of intrigue. Independent researchers have claimed that some of these signals appear to contain patterns too structured to be random. If true, this would suggest they are messages encoded transmissions from an unknown source. Could black holes themselves act as transmitters, sending signals through the universe? Could they be more than cosmic destroyers? Could they be cosmic broadcasters? An even wilder idea suggests that black holes are not simply objects, but enormous computers processing and storing information about the universe. If so, the strange signals we intercept may be data leaks, fragments of a far greater cosmic system. Every burst, every unexplained blip of radio noise, could be a piece of the universe itself trying to communicate. Spiritual and mystical interpretations go even further. Some believe that signals from the galactic center are not astrophysical at all, but cosmic messages meant for humanity. In this view, the black hole at the center of the Milky Way is not a threat, but a guardian, a gateway, and a beacon calling us to awaken to a greater reality. But the question remains, are these signals truly messages, or just random noise echoing through the void of space? For now, we don't know. What we do know is that the universe seems to be speaking and, whether through chaos or code, it compels us to listen. At the heart of it all sits the black hole, silent yet powerful, challenging us to uncover the truth behind the voices of the cosmos. Since the dawn of humanity, we've looked up at the night sky and wondered what lies out there. Black holes stand as both an answer and the greatest mystery of all. They are not merely voids that swallow everything in their path, but symbols of the unknown enigmas that have challenged the brightest minds, from Einstein to Hawking, and continue to puzzle scientists today. We've imagined them as cosmic monsters devouring stars, as gateways to other dimensions, as time machines, as vast cosmic computers, and even as broadcasters of signals from civilizations far beyond. Every theory, every hypothesis, reveals something profound. Black holes are not just objects in space, they are mirrors reflecting humanity's deepest curiosity. Perhaps, black holes exist not to be fully understood, but to keep us questioning, to remind us of how little we know, and how far we still have to go. Each time we think we've solved the riddle, they present us with another mystery. They embody both our smallness in the face of the universe and the limitless reach of our imagination. And maybe that's the point. Maybe black holes are not the end of everything, but the beginning of something new, something beyond our comprehension, waiting on the other side of the event horizon. Is it death, or is it rebirth? Is it silence, or is it a message? These are questions that may never be fully answered in our lifetime. Yet the call of the black hole will always be there, pulling us to look deeper, to dream bigger, and to ask what lies beyond the darkness. Now, the question turns to you. Do you believe black holes are cold, soulless objects of science, or are they cosmic beacons? Signals from the universe itself, reminding us that we are not the center of everything. If you love mysteries like this, don't forget to subscribe to this channel, turn on the notification bell, and share this video so more people can join us in exploring the unknown. Because here, every mystery is not just a story, it's a doorway to secrets waiting to be uncovered. Are you ready to step through that doorway?